Welcome back everyone, Patrick here, moving on to another question dealing with transformations of quadratics. So we got to describe the transformations on each quadratic here from that base function y equals x squared. So notice here we got y equals 3x in brackets squared, over here 1 over 2x in brackets squared, negative 1 over 3x in brackets squared, and then negative, right, the negative is outside of the bracket, and then we have positive 1 over 3x, and then that's going to be squared. So notice that these are sort of in a unique format that we haven't gone through in this section yet. Notice it's almost the same as that function, right? Y equals ax squared that we've gone through. But the difference is the constant is in the bracket and it's being squared as well. Notice here, this constant a, it's not in a bracket, right? This and this are entirely different, right? This and this are not the same thing. But these are in this kind of format. So if we potentially can take these and put it in this format, where the x squared is just going to be by itself, then we can know what the a value is and we can describe what it is. Notice how in this particular case, we don't really have to worry about the h or k, right? There's no like plus something or minus something, and then there's no like minus beside the x. It's not like x minus 4, for example, where the h value would be 4, or x plus 3, where the h value would be negative 3, right? There's no like plus or minuses, except the minuses. These aren't operations, they're just attached to the actual values, right? They're just negatives, they're not the subtraction symbol. So we don't have to worry about the h and k in this case. That's the first thing to notice, right? We're only gonna have to worry about the a, but we gotta get it in this format. So the question is, how do we do that? Well, just in general, to review exponential properties, if you have two terms in a bracket, and then you have some kind of exponent, let's call it y here. Let's use different letters than what we're using here. It doesn't really matter what letters you're using here, right? This is just a property I'm going over. But if you have two terms that are multiplying by each other, it doesn't have to be two terms either. It could be 3, 4, it could be an infinite amount of terms. But in this case, we're multiplying two terms. When you got two terms like this, what you could do is you could take that exponent on the outside and you could take it to the power of each term separately. Only if it's multiplying or dividing, right? So you could also do it if it's dividing like that. You could take the numerator to that exponent. You could take the denominator to that exponent, right? We're actually going to be using this as well when we're dealing with these fractions. So these are the two exponential properties we're going to be using. Now, it has nothing to do with this question, but remember, this is for multiplying and dividing. So this, if they're adding, okay, this is not a property, right? Or if this is subtracting, so we can do plus or minus there, right? This here, right? If you made this equal to that, it would be incorrect. Has nothing to do with the question, but thought I would just give a reminder so you always remember these exponential properties, right? It's only with multiplying or dividing that you could do that. So if we use this, okay, let's write this over here. If we use this property over here, notice the 3 is like the m, and then the x is like the n. So what we can do is we could take the 3 to the power of 2, then we could take the x to the power of 2. What's 3 to the power of 2? Well, it's 9, and then x squared is just x squared. And now notice, this is in that format, right? 3x in brackets squared is the exact same thing as 9x squared. And now that we have it in that format, we know the a value is 9, which means what? There's a vertical stretch by a factor of 9, right? It's not a vertical stretch by a factor of 3, it's a vertical stretch by a factor of 9. That's the trick. This might be a multiple choice question, and then that might be one of the choices, a vertical stretch by 3, but that would be incorrect, right? It's a vertical stretch by 9. And so that's what we're going to be doing for all of these over here. So if we go to the next one, notice same thing, we could take the 1 over 2. That's going to be to the power 2. And then we could take the x to the power of 2. Now, this is a fraction to the power of 2, meaning we could take the numerator to the power of 2. We could take the denominator to the power of 2, and then we'll just have the x squared like that. So 1 to the power of 2 is 1, 2 to the power of 2 is 4, x squared. So this is the same as 1 over 4 x squared. So notice in this case, what's the a value? 1 over 4. So what's the transformation? That is a vertical compression by 1 over 4. Right? That a value is between 0 and 1. If it's that case, we're dealing with a vertical compression. Right? So that's the first two. Then this one over here, we got negative 1 over 3x to the power 2. Now be careful with this negative here. You would still, first off, we take this negative, you put in the numerator or denominator. It's usually more proper to put in the numerator. So we would have negative 1 over 3 to the power of 2, then we'd have x to the power 2. So we got another fraction to the power 2, meaning the numerator goes to the power 2, then the denominator goes to the power 2, then we got the x squared. What's negative 1 to the power 2? That's positive 1. 3 to the power 2 is 9, x squared. So the a value in this case is positive 1 over 9. Notice 1 over 9 is between 0 and 1, so that's a vertical compression by 1 over 9. So notice this negative, because it was being squared, it ended up turning into a positive. All right, so that's a trick right there. You might think that, oh, it's a negative, this should be negative. If it was negative, there would also be a reflection in the x-axis, but there is none. Right, it's just a vertical compression by 1 over 9. If you take this, make sure you put the right format into Desmos, graph it, you'd end up getting a quadratic that opens up. Okay, it doesn't open down because that a value ends up being positive. Now this case though, is going to be a little bit different because the negative is now outside of the bracket. So what would happen is you got to be careful with your bed mass here because there's like a negative 1 in front. It's like by itself. That's multiplying by this, but with BEDMAS, we got to do the exponents first. So that negative 1, we would keep on the outside, and then we would do the exponential property, 1 over 3 to the power 2, and then we have x to the power 2, right? We're dealing with this exponential term first before the multiplication. So the negative 1 stays on the outside the whole time, then again over here, or sorry, let's write the negative 1 here. And then this fraction, the 1 goes to the power 2, the 3 goes to the power of 2, and then we have the x squared like that. So we'd end up with negative 1. 1 to the power 2 is just 1, right? And then 3 to the power 2 is 9. Then we got the x squared. And now combining these, negative 1 times 1 over 9 ends up being a negative 1 over 9. And then we got the x squared. So in this case, the a value is negative 1 over 9. Okay, so the case we're dealing with here is where that a value is between 0 and negative 1, right? With those cases we went through in the video when we talked about the a value. So an a value negative 1 over 9 means there's two transformations. There's a reflection in the x-axis, right, because it's negative. And then there's also that vertical compression by 1 over 9. You write the positive factor when you're describing a vertical compression or vertical stretch, even if it's negative. The negative just means there's a reflection. All right, so notice the difference between this one and this one over here, right? This negative was within the bracket, so it got squared away, quote unquote. It became positive, so there was no reflection. But this negative was on the outside. And so we ended up getting a negative a value, so there was a reflection in the x-axis.